Continuing in Chapter 5, Quadrilaterals, today we're going to cover Section 5.3, Theorems involving parallel lines. Your objective for today is, after studying this section, you'll be able to apply theorems about parallel lines and apply the midpoint theorems for triangles. Your class opener. Complete with always, sometimes, or never. Theorem 5.8. If two lines are parallel, then all points on one line are equidistant from the other line. So, if you know two lines are parallel, if I want to measure the distance from one line to the other, I have to go in the shortest possible distance, which would happen to be perpendicular to actually both of the sides. And if I do that over here as well, these distances happen to be congruent to one another. Theorem 5.9. If three parallel lines cut off congruent segments on one transversal, they cut off congruent segments on every transversal. So if these three lines happen to be parallel to one another, and if you knew that one transversal ended up getting cut into two congruent sized pieces, then any other transversal that I draw, no matter how it is, will also get cut off into congruent size pieces. Theorem 5.10. A line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. So let's start looking at this in pieces. A line that contains the midpoint of one side of the triangle. So if I go to this side and find the midpoint, if I want to draw a line that's parallel to another side, so I'm going to draw a line that happens to be parallel to the bottom. So if I draw this so it is parallel, what the theorem says is that the line will then pass through the midpoint of the third side. So over here should then be the midpoint, meaning I know that this gets cut into congruent sized pieces. Theorem 5.11. The segment that joins the midpoints of two sides of a triangle. So looking down below is really saying this. I know that the point on the left has to be the midpoint, and this point over on the right also has to be the midpoint. So if I draw in this segment that connects the midpoint of one side to the midpoint of the other side, then these two next pieces of information have to happen. It just so happens that one, it's parallel to the third side, meaning that this piece that connects the midpoints would be parallel to the third side of the triangle. The other thing that happens is this. It is half as long as the third side. So I'm really looking at it and saying the highlighted yellow piece is half of the distance of the green one. So if I came in here and labeled things, what I'd be able to tell you from the first piece of information is that segment BD is parallel to segment AE. So the second piece of information would tell me that the distance from B to D is half the distance from A to E. Let's look at some problems. M, N, and T are the midpoints of the sides of triangle X, Y, Z. So if I come in here and measure it, these are all going to be midpoints, so I know I have a bunch of congruent pieces. And let's see the information they tell me. So if XZ is 10, so the entire distance from X to Z is 10, I want to find out how big MN is. Well, since it's connecting the midpoints, it should be half the size, so half of 10 should be 5. Number 3, if TN is 7, and let's erase this information. So if Tn is 7, how big is xy? Well, connecting the midpoint should be half the distance of the other side. So xy should be double 7, which would be 14. Number 4. If Zn equals 8, so this piece is 8, how big is Tm? Well, I know Tm should be half of the third side Zy, and I already know that half of Zy is 8, so Tm is also going to be 8. Number 5. If xy is k, then Tn, well, Tn should be half of that, which is 1/2 k. Number 6 has a couple parts to it. So let's look at our diagram and label. If xy equals 10, so the entire bottom is 10, yz is 14, so the entire side over here is 14, and xz is 8, so the entire side over here is going to be 8. What are the lengths of the three sides of triangle TNZ? So let's look at triangle TNZ. So TNZ. Well, I know that in here I should have from Z to T is half of Z to X, so that's going to be 4. I know that from Z to N is half of Z to Y, so that's going to be 7. And I know from T to N should be half of X to Y, so that should be 5. Now let's look at part B, triangle MYN. Finding the missing pieces in here. Well, I know my is half of xy, so that's going to be 5. I know that ny is half of zy, so that's 7. And I know that nm is half of zx, so that's going to be 4. Let's move on to number 8. How many parallelograms do you see in the diagram? We'll give you a second to look. I know opposite sides need to be parallel. So if I look, here's one, x, m, n, t. So here's one parallelogram. A second parallelogram you might notice is right here. And there's a third one right up there. So you do get 3 different parallelograms. Looking at the picture below, what result of this section do the railings suggest? Well, if you look at the railings, they happen to be the same distance away from each other because all of the fence pickets are the same distance. So if all of these fence pickets are the same distance, then it should mean that the opposite sides are parallel to each other. So we should know that the railings are parallel to one another because they're the same distance away from one another. Your closure. Describe one of the main ideas of today's lesson.